Hi, who is online? Only Tanya, I guess. Tanya, can you hear me?
Hi, Professor. Yes, I can hear you.
Okay, so let me first clarify the problem we had during the class about the T distribution, right? So I'll explain again. What I was doing is correct, but in a way I kind of like got distracted with the standard deviation part. But let me do it again. So let me say there's a population. A population. Let me create a population of 100,000 people. So we create random array of 100,000 people with minimum. Let us say it's about heights. Let us say it goes from 160 to 180.
Are you sharing? I cannot see.
Okay, I think I didn't share the. Let me share it again. Yeah, can you see now?
But I think I will be able to see it. Yes, now I can.
Okay, so what it did is it generated a population of 100,000 people with heights between 160 to 180, right? So we do a sample, take a sample. Let's say we calculate confidence. We can use the word interval estimate between for unknown standard deviation, right? Unknown standard deviation. Okay. Unknown standard deviation. So we'll take like 10 samples. So we take it. Index. This is the array. And in between 100,000. We take 10 samples. 10 samples, right? We calculate mean. Here is the part we did mistake. The standard deviation, we can calculate standard deviation directly from the sample. We don't have to go for other ones. We can calculate the sample of the standard deviation. This is a mistake we have done. The standard deviation is for the sample, right? Standard deviation for the sample is this one. And the next we have to do is standard error. Standard error is, remember the standard error we were talking here. I'll show you the formula. Standard error is standard deviation divided by square root of n. Here we have this one divided by square root of n. Right? We have this. So everything is the same, remaining everything is goes the same way what we have done. So we have standard error, and what we want, for example, let us say we want let us see with Z and then we do with T so that we understand what's the difference. So let's say this standard this is the curve. Let's use the same curve for T and the normal distribution because it's just for symbolic way of understanding. So let's this is the mean. Let's the mean is, let us say the mean is at the same mean here. Actually it is mu, but what we want to do is just to want to estimate the extreme limits, right? So if we want to here and here. So let us say the percentage we want is confidence we want is 95%. So if you want a 95% confidence, let's use 90% to make it more simple. So if we need 90% confidence, what we do, this area should be 90. So this is 90. This area is 90. So what is the remaining area? The remaining area is 10. So we already know the remaining area is 10. So let's paint the remaining area, which is 10. We have 10. We have 10, the red one. So we know this part is only 5% because there is another 5% on the other side. So this is 5% of the area is here. Another 5% is here, right? So another 5. Oh, what's happening? Okay. Another 5% is here. Okay. So let's see what numbers we get. So this is 5% area. This is until here we have 90 plus 5. It is 95% area if we say in a cumulative way, cumulative distribution way. So we want to calculate this. Let me write this here. So we want a confidence interval, confidence, required confidence, let us say required confidence is 90. So what we have, the painted region and the black painted is 90. So the limit left limit is 5%. So how do I calculate 5%? It is 1 minus 90 divided by 2. But here it is 90%, so I'll put 0.9 and I'll write in percentage. Okay. This is the left limit. And what is the right limit? Right limit is this one plus this one, right? It's 95. But here I don't want in percentage, I want in normal number. So write like this. Okay. So for left and right, let us first do using normal distribution. Let's assume it's a normal distribution and see what happens. And I know it is wrong. So what I'm going to do is I'm going to put a red mark. So I'm going to use here a red one. I'm going to use a red one. Okay. So lower limit, upper limit. The lower limit is associated with the left one. The upper limit is associated with the right one, right? So the lower limit is, it is inverse of the cumulative distribution function. So what we do, normal distribution inverse. If we take here, it will allow us to take the mean and standard deviation. But let us do with the Z, because with the using the Z score, it will be more convenient to use the T. So I'll go with the standardized one, the standardized inverse. So if I use the standardized inverse, what we have, I have to give the probability. So the probability for the first one is 0.05, and the second one is, copy paste down. So we already know it's a symmetric. If I get this value, this will be the same one, right? So because they both are symmetric. Okay. So how do I calculate lower and upper limit? So how do I calculate lower and upper limit is, so we know the formula Z, let me write it here again. So here, Z is equals to X minus mu divided by sigma. So if I want to, from this, if I want to, I already know Z, I want to know X. So how do I calculate X? X will be equals to X equals to Z times, or say sigma times Z. Usually put constants before the variable, so sigma Z, and then plus mu, right? So we use the same formula. So we say sigma, here it is, this standard error we have to take, sigma times this one, lower limit, sigma times Z plus the mean. Here it is the mean. The same formula we copy below, but here I have to fix these values for the P. I fix this one and I fix this one. So I can copy down. So I get upper limit and lower limit as this. Now we know it is wrong because the standard deviation we are having is not from the population but from the sample. So when you use sample standard deviation, this is not applicable. So what is applicable? It is the t distribution. So I copy the same here, but I'll change the color to normal. And here, let me see what is he saying. Here, right? And this one, take it. I'll just put it for a while and then I'll change it. Okay, if you have like this, we used normal distribution before, but I don't want to use normal distribution. I want to use t distribution, right? So we say t inverse of the t. So inverse of the t is, we have to tell the probability, which we know, and also we have to say degree of freedom. The degree of freedom here is the number of sample elements we are taking, which is 10. So we put it 10. So we get, and we copy down. So we already know it is also symmetric. So upper limit and lower limit have same. If it is -1, it's going to be +1. So 1.8 minus 1.8. And here the calculation is the same. So we use the same calculations and we get the similar answers. So if we observe here, this is more precise, or we can say it is more narrowed down. It narrowed down the range, but here the range is wider. So what we can see is the precision is more when you use normal distribution. But the problem is we need to know exact value of the standard deviation of the population, which we don't know. So we can't go with this. We can only go with the t distribution, right? Okay. So this is how we apply that t distribution. So if anyone has joined, if you have any doubts, please ask me. I think only Tanya. So Tanya, if you have any doubts, please ask me.
But you said it was wider, but I see the same values. So I don't know. I don't see how it is wider.
You can see from here, it is minus 1.6 and here it is minus 1.8.
Okay. And what about the so we use t distribution when we don't have the standard deviation?
Yes, standard
But
deviation of the population. Yeah.
and what when we said on class
Mhm.
with regards to um, the number of the samples or the number of degrees of
Yeah,
freedom?
number of samples. I mean, these elements are the number of degrees because
Elements of the sample.
yeah, number of elements. Yeah, and also another important thing is when number of samples are more than sorry more than 30, we can directly apply normal distribution. So here we are having 10, right? So let us have more. Let us have more.
Number of samples or number of elements of the sample?
A number of sample elements. Yeah.
Okay.
So yeah. Okay. So this number of elements. So now we have 24, I guess. So let me have more than let us have more than 30. So we have how many now? We have 35, right? So when we have 35, we can directly go for the normal distribution. I will show you why. Let me first update the formulas. Because the value will be very, very close. So it's not a big problem. Standard deviation again. Standard error. Okay. So here we have this. Okay, here instead of 10, the degree of freedom now it is 35, right? So now if we see, these values are very close. So that's why we say when it is more than 30 samples, we can go with the normal distribution as well. Is it clear?
Yes, I think so. For now.
No, what I'm saying is if the degree of freedom is more than 30, it's the curve is very close to the normal curve. So it makes no big difference if you use normal or if you make t distribution. It's kind of the same because the values are very, very close. Okay. Yeah. Doubts? Any more
Yes,
doubts?
thank you.
Okay. I will stop this recording and I will make a new recording because